So, we know that machine learning is about teaching computers to learn from data. But what happens when a problem is incredibly complex? When the patterns are so deep and layered that a standard ML model just gets overwhelmed? This is where we level up. This is where we introduce deep learning. The official definition is a subset of ML using multi-layered neural networks to analyze complex patterns. Okay, let's unpack that. Think of a standard ML model as a single detective trying to solve a case. He can find clues, but it's a slow process, and some clues are just too subtle for him to catch on his own. Now, imagine a deep learning model. This isn't just a single detective, it's an entire hierarchy of them, like a whole police department, where each team has a specialized role. This structure is called a multi-layered neural network. Let's stick with our cat example. The first layer in this network is like the beat cop on the street. It looks for the most basic, raw details in a photo. We're talking simple edges, corners, or just spots of light and dark. It's the initial observation. The next layer is the forensic team. It takes those simple edges and corners from the beat cop and starts combining them to find more complex shapes, things like curves, circles, or straight lines. It's piecing together the initial evidence. After that, you have the senior investigator. This layer takes those shapes and starts to recognize actual features or objects. It might identify a furry texture, a pair of pointy ears, or the distinct shape of a whisker. Now we're getting somewhere. Finally, at the very top, the deepest layer is the chief of police. This chief takes all this complex, assembled information from all the layers below and makes the final, conclusive decision based on all the evidence. That is a cat. This deep hierarchy of analysis is what allows the model to understand incredibly complex patterns that simpler models just can't handle. It's the secret sauce behind the tasks that feel almost magical in today's technology. We see it everywhere. It's the power behind real-time language translation in a travel app, allowing you to have a conversation with someone who speaks a different language. It's the brain in a self-driving car, helping it navigate a chaotic city intersection safely. It's even a lifesaver in medicine, where a medical AI can highlight a tiny, hard-to-see tumor on an MRI scan, giving doctors a crucial head start. So, to recap, machine learning is the broad science of getting computers to learn and act without being explicitly programmed for every single step. Deep learning is a specific, incredibly powerful technique within machine learning. It uses these multi-layered neural networks to solve the most complex and nuanced problems we can throw at it, like understanding human speech, recognizing any object in an image, and even driving our cars. It's not just a single smart algorithm, it's a whole team of algorithms working together in deep, interconnected layers to see and understand the world in a way that, until recently, was uniquely human. Thanks for watching. If this helped you understand deep learning a little better, don't forget to hit that like button and subscribe for more deep dives into the world of tech. See you in the next one.